2.3b, remainder theorem. So a remainder theorem is basically when you do a synthetic division, you divide by x minus k. All right? So what can we use when we do x minus k? We can use what again? Synthetic. All right? And the remainder is actually just going to be when you substitute in k into your function. All right? It's pretty cool. So if I have this, I have 3x cubed plus 8x squared plus 5x minus 7. And I'm gonna use my k value of -2. Let's set up synthetic. So now I have -2 right here. And then I end up having 3 and 8 and 5 and -7. And then my little remainder box. All right, hopefully we're getting comfortable using synthetic because we're going to do it quite often. So we're going to drop 3. And then what do? We multiply. So we multiply and we get what? -6. And then we add and we get 2. And then we multiply, we get -4. Then we add and we get 1. And then we multiply, we get -2. And then we add, we get -9. So that's what we get as a remainder. We get a remainder of -9. So all the remainder theorem is I actually just do f of -2. And guess what it's going to be? -9. Now, on a test, that's all you'd have to do. I don't even care if you actually substitute it in or not. All right? You guys will have a calculator on the test. Will I actually know if you input it in a calculator or you just did that? I wouldn't know. I wouldn't know at all. But we're going to do it for kicks and giggles just to prove that the remainder theorem works. So if I have 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. What is -2 cubed? -8. -8 times 3 is -24. And then I have -2 squared, which is 4. 4 times 8 is 32. 5 times -2 is -10. And then I still have minus 7 chilling. So -24 plus 32 is 8. 8 minus 10 is -2. -2 minus 7 is OMG. What did I say it was going to be? -9. All right, so that's what the remainder theorem is. All right, pretty good? All right. On this one, we need to show that x minus 2 and x plus 3 are factors of this large fourth degree polynomial. And then we need to find the remaining factors, and we're even going to graph this thing. All right. What does it mean to have a factor? What's going to be my remainder if I have a factor? 0. So when I do synthetic, I better get 0. So let's set it up. What would be my k if I have x minus 2? 2, because it's in the form of x minus k, remember? So now I have 2. And then let's set it up. I now have my coefficients of 2 and 7 and -4 and -27 and -18. And then I have a little box. Now, what is going to be in that little box? 0. If 0 is not there, we did it wrong. All right? So let's drop 2. And then, what do I get next? 4. And then 11. And then -4 plus 22 is 18. 18 times 2 is 36. I add those and I get 9. And then I multiply, I get 18. I add, I get 0. Look at that. It's true. All right. So now I need to see if x plus 3 is a factor. And so I need to set my remainder thing right there. So what's my k now? My k is -3. So I drop 2. And I end up with -6, and then 5, and then -15, and then 0. All right, and that's where I'm going to stop actually every single time. All right, because I get a constant, I get an x, and I get an x squared. So if I actually write out my factored form right now, I'd end up with x minus 2, and then I'd end up with x plus 3, and then I'd have 2x squared plus 5x plus 3. And I stop there because I know how to factor a quadratic. All right, so how can we factor this quadratic? What does that factor to? Two x what? Plus 3 and x plus 1. All right. And so I now have those factors. So I'm going to actually graph this thing. So this would have a 0 of what? 2, 0. This would be a 0 of negative 3, 0. This would be a 0 of negative 3 halves 0. And then this is a 0 of negative 1, 0. What do all of them do? They all cut through. Why do they all cut through? Because it's an odd power. They're all first degrees, right? All right. What if one were squared? Then it would do what? Then it would bounce. But they all cut through. Now, where do I start? Where do I start? It's a positive even. Where does it start? Up. Where does it end? Up. All right. So it starts up, it ends up, and it's going to cut through everything. All right. Now, I don't need you to go all the way down like that, but it should look like something like a W. All right. Pretty good? All right. Fantastic. Let's keep moving. So, as a quick reminder, remainder in synthetic division, the remainder is equal to the value of it. If your remainder is 0, then what do you know? It's a factor. All right. Which basically finds an x-intercept of it. All right. Now we're on to 2.4. Now we're on to 2.4. And we're going to be talking about a complex number. To be a complex number is you have real things with what? Imaginary things. All right. So if I have a real number, that's our A, or our constants. And then I have plus BI. All right. So A plus BI is the standard form of a complex number, right? And this I thing, this imaginary number that you guys learned last year, this I is actually equal to a square root of what? Negative 1. Remember him? Yeah. And then you also had I squared. And I squared was equal to what? Negative 1. And then you guys also did I cubed. And I cubed was what? Negative square root negative 1. And then you guys also did I to the 4th. And I to the 4th was actually just what? 1. And it's actually a mod 4 system, and it just repeats each other after that. So I to the 7th is actually the same thing as I to the 3rd. All right? You guys following me? You guys remember doing that last year? All right, so now we're going to do complex numbers. Complex is really what? A real and an imaginary. All right? So here we go. I have 4 plus 7i plus 1 minus 6i. I know, this one's the tough one. This one's the tough one. Jacob, what do my real numbers go to? 4 and 1 are my real numbers. What do those go to? 5. Good. All right. And then 7i and negative 6i go to what? Just I. So I have 5 plus I. That would be the complex number of that addition statement. All right, look at B. I have subtraction going on. What would I highly suggest you do when you have a subtraction of a quantity? I Star Fox this. Choo, choo, choo. All right, you guys are more than welcome to do sound effects. All right, I encourage it, honestly. All right, so now we're just going to combine like terms. So my reals go together, my imaginaries go together. So what do my reals go to? Skipper, what do my reals go to? Negative 3. 2i and negative 2i, what do those go to? 0, so I don't need to put it. So I got negative 3. All right, do C and D. So on this first one, I'm going to distribute the negative on both of them. And so when we combine terms together, what do my constants go to? Courtney, what do my constants go to? I don't think so. They cancel out. They cancel out. And then how many i's do I have? Negative 5i. Very good. All right, calling somebody. Call on a buddy. All right, so we're going to distribute the negative. So what do my constants go to? 0. All right, how many i's do I have? 0. So what do we get? We get 0. Multiply. All right. So now we're going to multiply. So what am I going to do with this 4? I'm going to distribute. All right. So when I distribute this 4, I end up with what? Negative 8, and then plus 12i. All right. So that's in standard form of a plus bi. On part B, what are we going to do on part B? I have the quantity of 2 minus I times the quantity of 4 plus 3i. What are we going to do here? We're going to FOIL it. All right, my favorite 4-letter F word. So, what's my first? 8. My outer? 6i. My inner? Minus 4i. My last? Not plus, but minus 3i squared. Now, what is I squared? I'm going to replace that guy. What is I squared? Negative 1. So now I have negative 1 times negative 3, which is what? 3. So then I have 3 plus 8, and I'd end up with 11. All right. And then how many i's are left? 2i. All right. So now I have that in standard form. On part C, this is a special relationship that's being multiplied together. What is the name of this special relationship? They are difference of squares. I'll go with that. But does anybody remember the C word? Conjugate? They're conjugates. They're conjugates of each other. And what happens on conjugates of each other? The middle cancels. All right, the oi cancels of FOIL. So it's really just the Florida part, the first and the last. I have no idea how other states do this. All right, so when we do conjugates, it's really just the first and the last. All right, because the middle terms, they cancel. Are you guys following? So my first is 9. My last is what? Negative 4i squared. Now, I squared is actually what? Negative 1. So I do negative 4 times negative 1, which is 4. 4 plus 9 is 13. So I end up with 13 there. All right. This next part I have is 3 plus 2i quantity squared. So I just distribute this squared, right? Don't you dare. You'll get struck by lightning. We don't want that. All right. So we want 3 plus 2i. And it's really foiling with 3 plus 2i. That's how you should think of it. All right. It is not the first and last terms on that. So my first is what? 9. My outer is 6i. My inner is 6i. And then my last is 4i squared. All right. So I squared is actually what? Negative 1. So then this is 4 times negative 1, which is negative 4. Negative 4 plus 9 is 5. And then how many i's do I have? That would be awkward. All right. There you go.